Welcome back, dear grade 9 students, and as you see here, there is a circle and there are the lines and the ideas related to a circle that we have to know. And in this video and in the coming videos, we are going to talk about circles, angles, arcs, and stuff related to circles, arcs, and angles. First of all, a circle is defined usually by its center O and the radius R and its radius R. So what defines a circle is its center O. Usually we name it O, but it can be named any other using any other letter. Circle is usually used or named like a capital letter C between parentheses. So, and the radius R is usually called R in the uppercase or in the lowercase as well. And here we can say that OJ, OA, OB are all called radii. So either R like this or R like this, no problem. Now the plural of radius is radii, as you see here, where AB, that segment joining 2 points on the circle and passing through the center, is called the diameter, and the diameter has O, that's the center of the circle, as its midpoint, because B, O, and A are collinear and OB is exactly equal to OA because they are radii. As a result, AB, the diameter, is double the radius. So if the radius is 3, then the diameter is 6. If the diameter is 10, then the radius is 5. DE here, what you see here, DE is called the chord. It's a segment joining 2 points on the circle. AB, that AB, or for example BD, or AE, or AJ, all of these, AJ, or DE, all of these are called arcs on the circle. So arcs are like curves, not chords. Chord is just a segment joining 2 points on the circle, and we represent the arc by this, as you see here, by this gap. Now AOJ, that shaded part, AOJ, like the pizza slice, is called the circular sector. Now let's talk about the lines relative to this circle. Look at the green line. The green line here is T. It's called the tangent. The tangent to the circle is a straight line that intersects the circle at just one point, as you see here. That point of tangency, that's the point of tangency, and we're going to talk about it in details later. Now L, that orange line L that's intersecting the circle at 2 points B and D, is called the secant. So the secant is a line that intersects the circle at 2 points. The tangent is a line that intersects the circle at just 1 point, and here D is a line that's not intersecting the circle at all. We call it the external line or the exterior line that doesn't intersect the circle at any point. It's just outside the circle. So this is about lines and vocabulary related to a circle. Now in the coming slide, we are going to talk about relative positions of circles. Look at these two circles. These circles are not intersecting at all, so that's why we call them externally disjoint circles. So these are externally disjoint circles. For example, this is the radius R of the first one, and this is the radius R prime of the second one. There is a property concerning the radii that says that the distance between the centers O prime is definitely greater than the sum of the radii because there is a space here, there is a distance here. So in logic, O prime is greater than R plus R prime. Now what about these two circles? They are not intersecting too, and they are not even intersecting at just 1 point. They are not intersecting at all, so we call them also disjoint, but they are internally disjoint circles. Okay, and the relation concerning the radii and the distance between the centers is that O prime, the distance between O and O prime, is less than the difference between the large radius and the small radius. So the large radius is the radius referring to the large circle. This is R. Now let's see what we have also. Here are two circles that are intersecting at just one point. You can see it here. That's the point of tangency, of course. So let's mark it. That point of tangency, let's call it A, for example. Okay, so these are called externally tangent circles. And the distance between O and O prime is exactly equal. Look at it. That's the radius here, the big radius, and that's the small radius. So since there is no space in between them, they are just intersecting at one point, no space between the circles, thus definitely the distance between O and O prime is equal to the sum of the radii R and R prime. Notice that the centers and the point of tangency are collinear. They are on the same line. And finally, here we are with the internally tangent circles. They are two tangent circles, but from inside, here is the point of tangency, as you see. Okay, here is the point of tangency, and here is the large radius R of the big circle, and here is R prime. So notice that the distance between O and O prime is equal exactly to R minus R prime, the big radius minus the small radius. And let's erase these and go to the other slide that's going to complete the ideas about relative positions between circles. Here are the intersecting circles. So circles are either disjoint or tangent, just intersecting at one point, or even intersecting at more than one point, but maximum they are 2 points. So intersecting circles just intersect at 2 points. And the line holding the centers that you see here, OO prime, is usually an axis of symmetry. That means an axis of symmetry of the figure. That means if I fold the figure, I can get symmetry. The upper sides, the upper arcs, the upper angles, the upper segments are going to be equal to the upper parts, to the lower parts, sorry. And the relation between the radii and the distance between the centers is like this. OO prime is greater than the difference of the radii and less than their sum, where R is the larger radius. It's referring to the larger circle C. Now, concentric circles are circles that are having the same center as you see here. So you just put the compass, the needle of the compass, and you draw a small circle. Then you just widen the opening of the compass and to draw another bigger circle of the same center. You keep the needle on the same point. That's how to draw concentric circles. And here are equal circles. They are not necessarily of the same center. They are just equal. They have equal radii. So what defines or what specializes equal circles, that they have equal radii. R and R prime are here equal. And finally, when concentric circles and equal circles combined together, we are going to get confounded circles. So confounded circles have same radii and same center, then they are exactly like as if they are the same circle. You notice that the green circle is above the red circle, and that's what we call confounded circles.